Now, dear students, today we will discuss about the pending topic in jet transforms, that is residue method. Okay. So first of all, so I can remove the practice issues. Yes, this is the slide. So I have to first copy some problems. Like this is the first problem in residue method. And another name for this topic is complex. Another name is it is using complex integration method. Complex integrator methods or contour integration methods. Yes. Next. Yes. Yes. Find answers. I think the screen is visible to you. So first I can choose blueprint. Okay, today topic is residue method. So another name for this method is complex integral method or contour integration method. Complex method. Okay. So this is today topic. So in the residue method, first x of z is given, then you have to find out x of n. As we know that if x of n is the discrete signal, then the z transform is x of z. Okay. So how will you find out x of z? X of z is equal to n equal to minus infinity to infinity x of n z to the power of minus n. So this is the z transform. When x of n is given, then you can find out the x of z using the equation 1. But if you find if x of z is given, how will you find out x of n? The inverse z transform of x of z. Okay. So from the conventional method, so the equation is 2 pi j into x of z to the power of n minus 1 teacher. In the classroom, last class we have derived this equation. Do you remember, or if unable to remember, please open the notebook. Then you can see this derivation, last topic. Before last topic, it means last Friday. Yes. So here you have to find out this integral value, then you can find out the x of n. So already we have discussed two methods. Is a long division method or power series method, and second one is the using partial fraction method. Now it is the residue method. In the residue method, you have to find out this evaluation of this expression x of z into z power n minus 1 at each pole of the x of z. That means um, suppose like So this is the formula. Yeah, this is the formula. Okay, x of n is equal to residues of x of z into z power minus 1 at the poles of x of z into z power n minus 1 within C. The first you have to find out the poles of the Z transform. Then at each pole you have to find out this value. And that means substitute the pole value here in this expression. Then you can take the sum of all the values at each pole of the x of z. Suppose we will take one problem. This is the problem, right? Suppose if we say this is the problem. So for anybody, you can note down using residue method, find the inverse Z transform of x of z. Okay, how will you find out this? Okay, so for that to find out this x of n from the given x of z, you should use the residue method. Then we will discuss the procedure as per the given residue method rules. Okay, first one, what is the expression 1 plus 2 z power minus 1 here. So the given x of z, first you have to write down x of z equal to 1 plus 2 z power minus 1 by 1 plus 4 z power minus 1 plus 3 z square. 3 z to the power of minus 2. So here ROC is given mod z greater than 3. It is a causal signal, right? So it's a greater than value is a causal signal. Causal signal means so that will be x of n equal to 0 for n less than 0. Okay, that signal will exist only positive values. So that is, you have to find out the x of n. You can multiply with u of n default. So here this is the given x of z. First you have to enter the given x of z, and second step, so dealing with z power minus 1 is more complex with compared to z. So that's why the given fraction should be converted into z power positive powers. Okay, so that is, you can take 1 plus 2 by z, first one. Okay, z power minus 1 equal to 1 by z. So we can take 1 plus 4 by z plus 3 by z square. We can take LCM and simplify it. So LCM z, here z into z, 1 into 1, so z, so the 1 into z into 1 z, okay, z plus 2 by z by what, here also you can take LCM z square plus 4z plus 3 by z square. So this z and this z is cancelled. Then finally, what is the fraction? Z into z plus 2 by z square plus 4z plus 3. Then you have to find out the poles of this. Poles means the roots of denominator. So z into z plus 2 by, so you can take the roots z plus 1 into z plus 3. So this is the x of z. So next, as per the formula, you have to find out this, okay, x of z into z power minus 1. Next, third step is you have to multiply after finding the poles, x of z into z to the power of n minus 1. So z into z plus 2, x of z value I am writing, z plus 1, z plus 3 into, okay, z to the power of n minus 1. Yeah. So here z into z power n minus 1 is z to the power of n. So z plus 2 into z power n by z plus 1 into z plus 3. So this is the third step. Then how many poles are there? 2 poles. One is z equal to minus 1 and z equal to minus 3. So you have to find out this value of this at each pole and take the sum of. So that is x of n. So that is x of n. How many poles? 2 poles. The first one is z plus 1. So that's why first one you have to multiply z plus 1 into. So that is the value. Is z of x of z into z power minus n minus 1 ఏమొచ్చిందో అది సబ్స్టిట్యూట్ చేయాలి. z plus 2 into z power n, z plus 1, z plus 3. So first root is z power minus 1 కాబట్టి z equal to minus 1 plus ఇంకొక రూట్ వచ్చింది, ఇంకొక పోల్ ఉంది కదా z plus 3. సో దట్ ఈస్ ఆల్సో మల్టిప్లై విత్ z plus 3, x of z into z power minus 1. Okay, z plus 2 into z to the power of n, okay, z plus 1, z plus 3. So z equal to minus 3. Now simplify that. First z plus 1 is that's cancelled, z plus 3 is cancelled. You substitute z equal to minus 1 in this, z equal to minus 3 here. Then finally what? X of n equal to minus 1 substitute చేయండి, minus 1 plus 2, z వాల్యూ ఎంత ఇక్కడ minus 1 కాబట్టి minus 1 whole to the power of n by z plus 3 కదా, అంటే minus 1 plus minus 1 plus 3. Similarly here also same, minus 3 have to substitute, minus 3 plus 2, z plus 2 into z power minus 1 అంటే minus 3 sorry for disturbance, n by z plus 1 is there. Okay, denominator only z plus, sorry, z plus 3, this will cancel, it will available. So minus 3 plus 1. Yeah. Then what is the value? Minus 1 plus 2, 1 into minus 1 whole to the power of n by minus 1 plus 3, 2, plus here minus 1 by minus 2 into minus 3 whole to the power of n. So then what is the value here? One by 2 minus 1 whole to the power of n plus 1 by 2 minus 3 whole to the power of n. So this answer is this. Okay. So I have to multiply u of n because x of n is a causal signal based upon the ROC. It is a greater than the 3. So for to represent any signal as a causal, just multiply with u of n because u of n is available only in positive value. So that's why if you multiply any signal with u of n, the product becomes causal. So u of n minus 3 whole to the power of n. Now this is the answer. So in this way you have to find out the x of n from the given x of z. First you have to write down the x of z as it is from the question and find out x of z in terms of positive powers of z. Then check it whether how many poles are available in the denominator. From the your standard mathematics principles, and multiply with x of z with z power n minus 1. Because why you multiply with z power minus n minus 1? Because this is the derivation we have got. So that's why you have to multiply with x of z with z power n minus 1. Then you can get this equation. Then here, then how many roots are there? How many poles are there? 2 poles. Then from the equation here, then you have multiply. You have to find out the entire x of z power n minus 1 at z equal to minus 1, z equal to minus 3 by multiplying the corresponding roots like this. Then after that this will be cancelled. Then z equal to minus 1, apply that. Then you can take the sum of all the values. Then you can finally this one. So this is the residue method, a simple and efficient method with compared to the previous 2 methods. This is the topic. In the next video we will discuss about sampling for the that is a band pass signals, and also if any problems are appeared as a difficult and tricky for your external point of view, I can upload those videos also. Okay, please follow my channel and you can get the updates. Thank you.